In continuation with the change of order of integration part 1, in this lecture we will just present few more questions, more examples so that you can understand and learn the change of order easily. So let us take some examples. Now take this example. Evaluate 0 to a x square by a to x by a minus y into square root of ay minus x square dy by dx. So y has the variable limit y, with we will integrate with respect to y first, but you can see that y appears in the square root as well as outside. So is it, I think it is not very easy to integrate. We can integrate by brute force, but I'm thinking that it is not easy. So let us try to change the order of integration. So first we write the limits. So let assign us let assign this integral a name I, and now limits are what? X is equal to 0, x is equal to a, then y is equal to x square by a, and y is equal to x. These are the limits. Draw the graph. This x-axis and y-axis. This itself, y-axis is itself x is equal to 0, and take a point a comma 0. This line, this is vertical line parallel to y-axis, so this line is named x is equal to a. Now there are two other things. Y is equal to x, so y is equal to x is this line, and more accurately this this line. So this line is y is equal to x, and finally there is a curve y is equal to x square by a. So this is a parabola. And how do we draw the parabola? So you know that parabola we pass below this line, but up to which point and from which point? So you need to find out the intersection here. Intersection for what? Intersection of this parabola and this line. So you can also see when x is equal to 0, y is equal to 0, this is x is equal to 0 means parabola is passed through this point. And when x is equal to a means this line, then y is equal to also a. So this line will also intersect at a comma a, and this parabola will also intersect 8 comma a. So we do not need to find the point of intersection of these two curves separately. We have obtained. Now parabola will pass below this line in this region. Why? Because parabola appears in the lower limit. So this is parabola is y is equal to x square by a. Now this line is y is equal to x, and this parabola is y is equal to 1 by ax square. So this is our region. Now put the new limits. What is the minimum maximum limit of y? So this is the height, maximum height, and minimum height is 0. So y is equal to 0 to a. This point is 0 comma a. And what is x? So for x, take a horizontal strip. When you start moving from left to right, you will first meet this line, and here is x is equal to y, so x is equal to y. Then you will meet this curve, and at this curve x is equal to root ay, so x is equal to root ay. These are the new limits. So write the new integral, means integral with order of integration change. So I is equal to 0 to a, this is limit for y, and y to root ay, this is limit for x. And write down x by is a minus y square root of ay minus x square dx dy. Now we will integrate this first with respect to x. So see that x appears here, and in the numerator this factor is not disturbing the integration with respect to x, means it is not related to x directly in the first internal integral. So write this as 0 to a 1 by a minus y, and the integral y to root ay xy square root of ay minus x dx, this and dy. So we take this part between the brackets, means green integral, as I1. So let us take is I1, and our integral will become 0 to a I1 by a minus y dy. So we will evaluate this later. First we evaluate I1. So what is I1? I1 is I1 becomes y2 root ay, then xy square root of ay minus x square. Here y will be treated as constant because integration is taking place with respect to x. So let ay minus x square is equal to z square. This will give, keep noted that y is constant here. So minus 2x dx is equal to 2z dz, and in turn x dx is equal to minus z dz. And what about the limits? So when you put x is equal to root ay, this will become ay minus ay. The limits of z are 0 when x is equal to ay. So I am writing the new limits to avoid your confusion. So when x is equal to ay, z is equal to 0. When x is equal to y, so we have ay minus y square. So ay minus y square, and this is equal to z square. So z is square root of ay minus y square. So these are the limits of z. Z is equal to ay minus y square. These are the limits of z. And now this x dx is minus z dz, and below ay minus x square is z square. So this square root equals z. So z cancels out, and we get simply z as integral. So limits are ay minus y square 0. So and minus 1 is here. So we get square root of ay minus y square. This is I1. I1 is equal to square root of ay minus y square. Now put this I1 in I. So I is 0 to a I1 by a minus y dy, and this is 0 to a square root of ay minus y square divided by a minus y. So you can take y common from the numerator. So when you take y common from the numerator, you get I is equal to 0 to a, and root ay a minus y by a minus y dy, and this happens to be 0 to a root y by root a minus y dy. Now we can take some substitution. Let y is equal to a sine square theta. This gives dy is equal to 2a sine theta cos theta d theta, and the limits are changed to 0 to pi by 2. So I is now I is equal to 0 to pi by 2. Why 0 to pi by 2? When you take y is equal to a by a is 1, so sine square theta is equal to 1, therefore theta is equal to pi by 2. Theta is equal to minus pi by 2 is also a value, but that will be in the third and fourth quadrant, means between the third and fourth quadrant, and the region 0 to minus pi by 2, this 0 to minus pi by 2, this is not the region of our concern, so we take limit as 0 to pi by 2. Now put these things. What is root y? Root y is root a sine theta, and then in the numerator a minus y, so y is a is sine square theta, so root a can be taken common, root a can be taken common, and then 1 minus sine square theta is cos square theta and square root, so we get cos theta, and then dy is 2a sine theta cos theta d theta. You can see this cos theta cancels this, and this square root a cancels this, so we just get 2a 0 to pi by 2 sine square theta d theta. And as we have learned in the multiple integrals previous lectures, this has a set formula. This can be written as gamma 3 by 2 gamma 1 by 2 by 2 gamma 2, and this evaluates to 2a 1 by 2 root pi for gamma 3 by 2 and root 5 for gamma 1 by 2, and gamma 2, this gamma 2 is factorial 1 means 1, so by 2 2 cancels 2, and finally we get a pi by 2 as our answer. So this is the answer. We have integrated this after changing the order, and it is easier than the original one. You can try to integrate this directly and feel the level of difficulty. Now take this example. Evaluate 0 to 1 x square to 2 minus x double integral xy dy dx by changing the order. So this integral is actually not tough. You can integrate it directly, but the intention behind this question is something different. So let us start. Let I is equal to 0 to 1 x square to 2 minus x xy dy dx. What are the limits? Limits are x is equal to 0, x is equal to 1, and for y, this is y is equal to x square and y is equal to 2 minus x. This is actually x plus y is equal to 2. So this is lower limit, lower curve, and this is upper limit, so upper curve, lower curve, upper curve and lower curve, upper curve and lower curve. So try to draw the bounded region. This is x-axis, this is y-axis. So y, we have x is equal to 0, y-axis is x is equal to 0, and a point 1 comma 0, take it on x-axis, so that this line is x is equal to 1. So we have two lines, x is equal to 0 and x is equal to 1. Now what is y is equal to x square and y is equal to 2 minus x? So y is equal to 2 minus x is x plus y is equal to 2. So this will intersect at 2 comma 0, 0 comma 2 at y-axis, and 2 comma 0 at x-axis. So draw a straight line joining these points. This line, this line is x plus y is equal to 2. Now where does this parabola lie? So you need to check the intersection. So you can check the intersection with the this line, and you can check the intersection with this line. So anyway, when x is equal to 0, y is equal to also 0, so curve obviously has this point in the region origin. Then when x is equal to 1, y is again 1. So this parabola curve the line x is equal to 1 at 1 comma 1. Now we have to see what is this point. So for this point, you can see this line is x plus y is equal to 2, and this line is x is equal to 1. When you put x is equal to 1, y comes out to be 1. So this point is 1 comma 1. So let us put this. This point is 1 comma 1. So y is equal to x square. This parabola also intersect at 1 comma 1. So this will go something like this. So this is the curve that we want, and there are again two bounded regions. So which bounded regions we are interested in? So mark that lower limit is line, this line is lower limit, and this parabola is upper limit. So in the bounded region, line should be above the parabola. So in this region, this line is above the parabola, so we are not interested in this region. This is not the region of our interest. Now we have obtained the region. This is our region. This is our region. So start putting the new limits. New limits means limits of changed order. So what is the maximum value of y and minimum value of I? So y ranges from 0 to 2. Y ranges from 0 to 2, mean minimum value of y is 0 and maximum value of y is 2. So y is equal to 0 and y is equal to 2. These are the values for y. Now what to values of x means how to find the limit for x. So see that you have to draw over horizontal strip. So there is a twist. When you draw a horizontal strip in this region, the lower limit of x is 0 and upper limit of x is from this line, means y minus 2 minus y. And when you draw vertical strip in this region, the lower limit is again x is equal to 0, but upper limit is from the parabola. This parabola is y is equal to x square. So x is root y. So we have same starting limit of x, but two ending limits, means two upper limits. So accordingly we have to change the integral, and we have to break into two parts. So from where we will break at this point. This is the point where we break. So this is one region and this is another region. So what is this point? This is y is equal to 1. So now break this into two parts. First part, integral y from 0 to 1, and second y from 1 to 2. Then for the first region, this region is y from 0 to 1. So x starts from 0 and it end at the parabola. So x is equal to root y. Mark that x is equal to plus minus square root y, plus minus square root will lie in second quadrant. So that is not of our interest. And in this means 0 to 1 to 2, this portion y is from 1 to 2, then x starts from 0, so 0 and ends at this line. So from equation of this line is x plus y is equal to 2, so x is 2 minus y. So we have two different integrals. This is why I have taken this question. Otherwise, the question is very easy to integrate. But you have to learn that from this question you will learn that sometimes the integral after change of order is not one. It breaks into two and three parts. It may break into three parts or may break into two parts, and uh, counter side is also possible. Sometimes it may happen that when you combine the two integrals and change the order of integration, you get one single integral. So now write the integral I is equal to 0 to 1 value for y and 0 to root y value for x in first region, and then xy dy dx plus in the second region y is 1 to 2 and x is 0 to 2 minus y xy dy dx. Now we will integrate it. So is equal to I is equal to 0 to 1, 0 to root y xy dx dy plus 1 to 2 and 0 to 2 minus y xy dx dy. So you can integrate these separately or just integrate, because the integration is not tough. So this becomes 0 to 1, and when you integrate at x it becomes x square by 2 with the limits of integration 0 to root y and then dy plus 1 to 2, then integrate x, so it is x square by 2 again, and the limits are 0 to 2 minus y and dy. So just put these values, so we get 0 1 by 2, you can write 1 by 2 outside the integral. So this is 1 by 2, 0 to 1, and when you put root y for x square, this become y, so we get this y square dy plus 1 by 2 taken outside the integral 1 to 2. When you put x square, uh, when you put 2 minus y for x means the upper limit, lower limit is 0, this upper limit, lower limit is 0. So when you put this, you get y into 2 minus y whole square. So you get this y into 2 minus y whole square dy. Now I hope that these are very easy integrals. This is directly y cube by 3, and for this one second integral you can open and expand in the powers of y and integrate. So it is very easy. You have performed such integration many times, and the answer comes 1 by 6 for this and 5 by 24 for the second. So finally we get 3 by 8. So this is what we evaluated after changing the order. What we learned from this integral, that after changing the order, integral breaks into two parts. Now finally we again take an integral which is not easy to integrate directly. This is 0 to infinity 0 to x, x e to the power minus x by y. I think minus is not clearly visible here. This is minus x square by y dy by dx. So you can see that y has variable limit, so you need to integrate with respect to y first, but this has a problem. E to the power minus x square by y, integral of this with respect to y is very tough. So you can try to integrate this, but we are going to change the order of integration and see how up to which level the easiness comes. So let us start. Let I is equal to 0 to infinity, 0 to x e to the power minus x square by y dy dx. So first write the limits. Limits are x is equal to 0, x is equal to infinity, then y is equal to 0 and y is equal to x. This is infinity, infinity. So now draw the graph. This is x-axis, this is y-axis, and x-axis, y-axis is x is equal to 0 and x-axis is y is equal to 0. So these are the two lines, and other one is x is equal to infinity. So you can take a virtual line and say that it lies at x is equal to infinity. Then finally we have done three lines. Then finally is y is equal to x. So y is equal to x is this one, and you name this is y is equal to x. So which region we should find, because infinity bounds all the plane, the complete plane. So we have this region and this region. So which one we should select? So again, learn from the previous question and remind that y is equal to x should be upper curve and y is equal to 0 should be lower curve. Y is equal to 0 is what? X axis. So x axis should be below, y is equal to x in the region. So this is our region of interest. So this is our region. Now we have identified the region. So write the new limits. New limits. New limits means limits after changing the order. So for new limits, write the minimum and maximum value of y. So y has the minimum value 0 this point, and as you go on in this region, so y increases indefinitely. So again y is also infinity. Here this is height of y, this is height of y, and what will be y at x is equal to infinity? It will be infinite. So again y has also infinite value in this region. So upper limit of y is infinity. So y is equal to y is equal to 0 to y is equal to infinity. And then for the limit of x, draw a horizontal strip and start moving from left to right. So first you will meet, this is the region. Keep remember that this is the region. uh, Let us denote this cross. So this is the region, this is the region. So you will first visit this point, means you will first meet this line y is equal to x. So this is the lower limit, sorry, x is equal to y. So this is the lower limit, x is equal to y, and you will end up with infinity. So x is equal to infinity is upper limit. So now what is the new integral? Means integral with change, the order change. So this is 0 to infinity for y, and then y to infinity for x, and x e to the power minus x square by y dx dy. Now we will integrate first with respect to x. So when we integrate with respect to x, let us take this as I1, so that our integral becomes 0 to infinity I1 dy. So first integrate I1. What is I1? I1 is I1 is y to infinity x e to the power minus x square by y dx. So if we take the substitution, x square by y is equal to z, that means x square is equal to yz, and because y is constant here, so 2x dx is equal to y dz. And this x and this dx will for y dz. So we will get, and what are the limits? So you can see, when x is equal to infinity, then z is also infinity, and when x is equal to y, then from the formula, watch this, when x is equal to y, z is again y. So y to infinity, limits of z are also y to infinity, and in x, this dx means x dx is equal to y dz by 2. So half y dz, and e to the power minus x square y. So this is e to the power minus z. So this is e to the power minus z and dy. So you can see that e to the power minus, sorry, this is dz, this dz, e to the power minus z dz, and you can see that y has no role for integration here. So you can directly integrate e to the power minus z. So write 1 by 2 y 0 to, sorry, y to infinity, 1 by 2 y to infinity e to the power minus z dz. So you can integrate this. This is very easy. 1 by 2 y, and then e to the power minus z by minus 1, and limits are y to infinity. So put the limits, 1 by 2 y at upper limit e to the power minus z, and z is equal to infinity, this will become 0, minus at the lower limit it will become e to the power minus y and by minus 1. So what we obtained, I1 is equal to 1 by 2 y e to the power minus y. This is I1. Now put this I1 in I. So write I was 0 to infinity I1 dy. I1 dy. So I1 we have obtained. So put in this integral. So we get 0 to infinity 1 by 2 y e to the power minus y dy. And this is a very trivial integration. You can integrate by parts. So this become minus 1 by 2 minus 1 by 2 y plus 1 e to the power minus y, and limits are 0 to infinity. At the upper limit the integral will become 0 due to e to the power minus y, and at the lower limit e to the power 0 is 1, y is 0, so you will get 1 by 2. So finally we obtained 0 to infinity, 0 to x, x e to the power minus x square by y dy dx. This is equal to 1 by 2. However, this is not very easy to integrate directly, but after change the order of integration we evaluated very easily. So finally this is also an outcome, and this is the special outcome why we change the order. So purpose of changing the order of that, in some order you cannot easily integrate, or even you cannot integrate sometimes, but with the change order very frequently, many times it is possible that the integration is possible. So let us stop this lecture here, and we will learn the new topic in new lecture. In next lecture, we will start a series of lectures for vector calculus, and that will consist of vector identities, means differential identities of vectors, and vector differentiation, then line integral and vector integration, then some theorems such as Green's theorem, Stokes theorem, and Gauss theorem. These will be theorems of vector calculus. So in next series we will start and present the vector calculus. So stay connected. If you are interested in vector calculus, then watch the next series and wait. Thank you.